Hello GCC, we're back. We are going to talk about intermolecular forces in this video and typical questions we ask. But quickly, let's just summarize what we've learned in the first two videos. Chemical bonds hold atoms together in a molecule or a compound. Bonds hold atoms together. We have ionic bonds. That is when electrons are transferred from the metal to the nonmetal so that the metal lost an electron and became positively charged, and the nonmetal gained the electron and became negatively charged. And then these opposite charges attract each other. Again, it's typically between a metal and a nonmetal, or we can have polyatomic ions in ionic compounds, right? Because they're ions also. Then we have covalent bonds. This is when electrons are shared, not transferred, but shared between non-metal and other non-metal atoms. Covalent bonds can be polar or non-polar. Polar is when we have two different non-metal atoms, so one pulls the electrons more, so they're shared unequally. Or we can have non-polar. That's when the atoms are the same, so the electrons are right in the middle. So the electrons are shared equally when atoms are the same, or CH bonds are also non-polar. Now let's review our intermolecular forces real fast again. London dispersion forces. Again, intermolecular forces hold molecules together. Molecules. So an IMF holds molecules together. The London dispersion force is experienced by everything, but we're going to focus on the fact that it's the only force that a non-polar molecule will have. So non-polar molecules go with London force. That's the only force they have. Dipole-dipole forces is for polar molecules. Polar molecules can have dipole-dipole forces, which are stronger than London. Hydrogen bonding force is between a hydrogen of one molecule and an N or O or F atom on a different molecule. Again, the hydrogen's a little bit positive, the N or O or F is a little bit negative, and opposites attract. So you have to have a HN or HO or HF bond within a molecule to do this. Again, hydrogen connecting to an N or O or F. And then the last one is the ion dipole force. The ion dipole force is between ions, ion dipole, and polar molecules. Polar molecules have two poles, dipole, so it tells you what it is, the ion dipole force. All right, what kind of questions do we ask? Well, we want to know what the strongest force is in a sample. So here we have some samples on the left side, and we're going to determine the strongest intermolecular force in that sample. It is helpful to know if the molecule is polar or nonpolar. So let's look at CO2 first of all. CO2. Well, is that polar or nonpolar? Is it London force or dipole-dipole force? We know it's not hydrogen bonding force because there's no hydrogen. And it's not the ion dipole force because we don't have any ions. This is a covalent molecule. So it's got to be one of the first two, London or dipole-dipole. So we need to know if it's polar. Well, for that, you're going to have to do a Lewis dot structure. So this is a good time to review how to do Lewis dot structures. You add up your valence electrons. Our carbon is going to be in the middle, by the way. It's the center atom. And if you want to pause and do a Lewis dot structure real quick. Okay, we're back. If you did the Lewis dot structure correctly, you have C in the middle with an O on either side. It's linear, not bent, but linear. And for that reason, the two poles cancel out, right? The CO bond is polar in one direction, but the other CO bond is polar in the opposite direction. So the poles cancel out, making CO2 non-polar. It's non-polar. What is the strongest force you can have in non-polar samples? You're correct if you said London dispersion force. London dispersion force. All right, PF3. P and F are different atoms, but we need to know if it's polar or nonpolar. Again, there's no hydrogen, so it's not hydrogen bonding force. There's no ions, so it can't be ion dipole force. So again, we need to know if this is polar or nonpolar. We have to do a Lewis dot structure again. So hit pause and draw the Lewis dot structure. And we're back. PF3 is not symmetrical. The P has 3 fluorines coming off of it, but there's a lone pair above the P. Okay, so it's very asymmetrical, which makes it polar. Okay, PF3 is polar because the poles do not cancel. It's a trigonal pyramid shape. If you look at your shapes table, it is the AB3E. Can you see that trigonal pyramid right there? See how there's a lone pair on top? Yeah. So it is polar, AB3E. It is a polar molecule. What force goes with polar molecules? You're correct if you said dipole-dipole. Good job. All right, next we have HF. Now this is just 2 atoms bonded together, so we do not need to do a Lewis dot structure. H to F, is that a polar bond or a nonpolar bond? Well, they're different, right? F is closer to F, so it's going to be a little negative. H is going to be a little positive. It is polar, but it is an H bonded to an F. What do we know about H bonded to F? What kind of force is that? You're correct if you said hydrogen bonding force. It is a force, hydrogen bonding force. Next up, CH4. This is a CH chemical. Now you may remember back when we talked about polar and nonpolar, anything that only has C's and H's is going to be nonpolar, right? Carbon-carbon bonds and carbon-hydrogen bonds are all nonpolar, so the molecules have to be nonpolar. So CH anything is nonpolar. Don't waste your time doing a Lewis dot structure. C2H4, C3H8, C6H10, anything CH is nonpolar. Don't waste your time doing a Lewis dot structure. It's nonpolar. What force goes with nonpolar? You're correct if you said London dispersion force. Good job. The last one looks different. We have potassium iodide aqueous. Aqueous means it's also in water. So we have water and potassium iodide. Well, Ki is different from all of the other molecules in this list. It is ionic. And we have water, which is polar. So we have something ionic in polar water. What force could that be? You're correct if you said ion dipole force. Good job. All right, so this is definitely something we're going to ask you about. What is the strongest intermolecular force in a sample of? Okay, so review how to do your Lewis dot structures. You may have to determine polarity of a molecule. What else do we ask? Well, we like to ask the question, what holds the following together? If it is atoms being held together, you pick a bond, an ionic bond or a polar covalent or nonpolar covalent bond. If it is molecules being held together, you pick one of the 4 forces. All right, let's give this a try. Number 1, what holds atoms in an ammonia molecule together? Atoms. What holds atoms together? That would be a bond, right? So we need what holds N to H bonds together, NH bonds. Well, that's not a metal in there, so it's not an ionic bond. It must be a covalent bond. And we have N bonded to H. Those are 2 different nonmetals. So that would be a polar covalent bond. All right, number 2. What holds sodium +1 ions in water? So we have water molecules. So we have molecules. Molecules means it's a force. We're looking for a force. What force would hold sodium ions in water? Okay, that one's pretty easy. It's that ion dipole force. Good job. All right, number 3. What holds 3 HCl molecules to each other? Molecules together. Well, what holds molecules together is a force. So we're looking for a force that goes with HCl. HCl. We have an H, but it's not bonded to an N or O or F, so it's not hydrogen bonding. We don't have any water, so it's not ion dipole. So is HCl polar or nonpolar? We have an H and a Cl bonded together. They are different. So that is polar. What force goes with polar? Dipole-dipole force. Good job. What holds the ions together in salt? NaCl. So Na plus and Cl minus. Na and Cl. What holds those together? So those are charged atoms being held together. Atoms being held together is a bond. So we're looking for a bond between Na plus and Cl minus. Na is a metal. What kind of bond goes with a metal and a nonmetal? Ionic bond. Yeah, good job. All right, next. What holds 2 water molecules to each other? Molecules being held together. So that's a force. Okay, what force goes with H2O? We have an H bonded to an O. You're correct if you said hydrogen bonding force. Good job. We have an H bonded to an O, so it can do that H bonding force. Yeah, we have an H bonded to an N or O or F. We have an O. Nitrogen gas molecules to each other. Molecules. Again, that would be a force. Forces hold molecules together. Nitrogen is N2. N2. N bonded to itself. Are we polar or nonpolar if we are bonded to ourselves? N to N. Well, those are the same. So the electrons are in the middle. So it is nonpolar. What force goes with nonpolar? London force. Good job. All right, what holds the O atoms together in an oxygen, O2 molecule? Atoms. We're holding atoms together. So it's got to be a bond. What bond goes with O to O? Is there a metal? No, so it can't be ionic. It must be covalent. Are we polar or nonpolar when we're bonded to ourselves? O to O. We're nonpolar because the electrons are in the middle. So it's a nonpolar covalent bond. Nonpolar covalent bond. All right. And the last one. What holds 2 ammonia molecules to each other? 2 ammonia molecules. Okay, that would be a force. Now, ammonia was given in the first one as NH3. So we have an N bonded to an H. What force goes with N bonded to H? Hydrogen bonding force. Yeah, hydrogen bonding force. There it is. Okay. All right, so those are the types of questions we ask. Good job. See you in the next video.